Hey everybody, so it's Tony from Adafruit, and hopefully this is streaming, first time kind of using Twitch, so we're going to do some Raspberry Pi hacking and kind of play with a physical dashboard project that I did earlier in the week, and we'll see if we can hook it up with Adafruit IO and kind of get the Internet of Things to the physical dashboard here. So I'll show you real quickly the setup I've got. So there's all kinds of fanciness here. There's the shot of me here just straight on with my head. We've of course got the cat cam that we might check up on. She's kind of right behind me to the back there. And then I've got desktop and workbench shots. So let's jump to the workbench right now. So this is just over here to the left of me, and actually I can put my head over here too, so you can kind of see both of these. So this is the Raspberry Pi physical dashboard right here, which is a project last week that I published that kind of shows you how to use a Raspberry Pi to display data, and it's blank right now, so these are just little 7-segment displays on here. There are these neat little dashboard or neat little backpacks that have kind of the driver integrated on there, and they connect just over an I2C interface, so it's really easy to interface these with different devices like the Raspberry Pi down here. So let me hide my head and you can kind of see the Raspberry Pi. So what we'll do is we'll hook up the dashboard, and I'll kind of run through real quick just the general setup of using the physical dashboard. We'll display some data on the gauges here, and then we'll go and actually hook this up to Adafruit IO, the Internet of Things service that we have, to see how easy it is to send data down to this dashboard here. So I've actually got off to the side here a little ESP8266, and this is a DHT22 sensor, which is like a humidity and a temperature sensor. So we'll use that and hopefully stream the data to the dashboard here. So let me jump to the desktop view real quick, and hopefully this is working. Okay, cool. So this is the tutorial that we have on the learning system. So you can go and check out, there's a little video here that kind of walks through the project, and you can see the general idea is that you can build a little dashboard to display any kind of data. So I have two examples of the dashboard here. There's one that uses a little bit of a whiteboard, foam board, to show like you know, an automotive gauge here that kind of moves around like a dial. There's a alphanumeric display that you can use to display small little text messages, and an LED bar graph here that's kind of neat. You can light it up in different colors like green and red and yellow. And then on the right is what we were looking at before, just with some text and things on here. This is actually chalkboard foam board, so you can write on it with chalk, you can erase it, and you can label everything here and say that, you know, this is like CPU usage if you're monitoring a server or something like that, uptime, how many days it's been up. So the idea with this is that, you know, it's a dashboard, it's showing you data, but it's a little more interesting than just like a monitor. Like a lot of times you might see someone might have a computer monitor that's displaying a web page, and it's, you know, showing you maybe server load, something like that. And it's easy to kind of tune that out. You know, you see this monitor and it's like, oh, it's just another TV somewhere. So the idea with this is that you can have these different outputs, these different displays, and you can put them on something that's a little more kind of handmade, a little more interesting. So, you know, like a chalkboard or a foam board. And because you can erase these and reuse them, you can just change the labels if you decide, okay, I don't want to measure server load anymore. Maybe I want to show temperature or things like around the house. So it's easy to change this and have fun with it. So what I'll do is I'll jump into setting up the Raspberry Pi. So let's jump to the workbench shot here. So let's see, I'll go in and I'll show you kind of what I've got on the bench here. And actually, let me just go to workbench only. So I've basically got the dashboard here, and this is real simple and straightforward as far as how I assembled it. So you can see it's just the LED backpacks, they're taped on, and they're just connected with a little IDC connector. That's just because I have male headers here, and I need to be able to connect this to female headers on this breadboard over here. So this works well. You could use like a female cable also, so, you know, anything to connect these. And the connections are really simple. So for this top dash or this top display, it just needs the I2C communication pins. So there's a clock, a data, it needs a ground. Now the top one, because it's a larger display, it needs 5 volts to really power it with a bright display. But the other displays, they only need 3 volts. So this top one needs 5 volts, and then it also has a little I/O voltage level, which just tells it, even though the display is powered by 5 volts, the actual I2C bus is running at 3 volts, so it's a little bit less. You do have to be careful because if you put a 5-volt thing on the I2C bus, it could raise the level of the bus to that voltage, and the Raspberry Pi really doesn't want to deal with 5-volt inputs like that, so you could damage it. So let me just reconnect this back up. And this is just a piece of the chalkboard foam board. Kind of looks like this, just basically black foam board, but you can write on it with chalk. That's kind of neat. I found this at a craft store, just like a Michaels or Joann Fabrics. Any of those stores probably have it, and it actually comes in this little 8x10 pre-cut size that works really well. And then I just cut out a little square here with a knife and put the LED displays here. So this is what the backpacks look like. This is the 1.2 inch backpack, and this is, I think, the 0.56 inch backpack. And you can get basically any color. So it comes as kind of two things, like you choose what color you want for your display. So I think this one, the big one here, is a red one. The one over here, I didn't label that one. So you can have, there's pretty much every primary color. You can pick one. And then it connects to the little backpack, so you solder it on here. And this is just a Holtec LED controller that can be communicated with over I2C. So you don't have to run, each of these little LEDs, each of these segments is a separate LED. So if I wanted to drive this whole display without that little backpack, I'd have to have 20-something plus pins. And on a Pi, you don't have that much GPIO, so you do have to be careful about that. And so that's what makes it nice, and that you're using I2C. The other nice thing is that multiple devices can share that I2C communication bus. So I have 3 displays on here, and you can see the other ones down here. And the one thing you have to do is you have to be careful about the address of each device. So on the left over here, on these little backpacks, there's these 3 little bridge points that you can change. You can solder, you can bridge them closed to change the address, and that just changes the bit value. And we'll kind of see as I get this wired up what it means and how you can actually detect these devices. So let me go ahead and connect the wires real quick and get this hooked up. So I've just got all the displays connected here with the IDC cables, and on the Pi over here I just have the Pi cobbler going to the little breadboard here, and I've pulled out already the 3.3 volt power line over here, the ground power line, and then also the 5 volt line is this white one because I need one 5 volt signal for the big LED display, and then the clock and the data lines over here. So it's pretty straightforward to hook these up. I'm just going to do the I2C clock to clock and data to data line. So the orange one is the data line that I did ahead of time. So I'll hook these up. And the yellow one is the clock line. So I'll hook this up. And then ground goes into my ground. And power, let's see, this is a small display, so it needs 3.3 volt power. So I'll plug this into the power line. And same thing for the other display. So this is the other small one here. So I'll hook it up the same way. So yellow is the clock, and orange is the data, and 3.3 volt power again, and then the ground. And the last one is the big display. And so this one's pretty similar, but just one little change that I'll show you. Oops, let me see if I can rearrange these cables a little more. Alright, so clock to the clock line. Oh, and actually I have these hooked up on the wrong row, so that could be a fun problem if you didn't catch that. And I've actually, so the Pi, I've just loaded it with the Raspbian Jessie Lite operating system, and I haven't done anything to it yet, so we'll kind of walk through the whole setup, and it's actually pretty quick. And the Lite distro is really nice if you're a Raspberry Pi user. The Lite distro is kind of a new version of Raspbian. It's exactly the same as the current one, it just includes less software out of the box. So it's a smaller download, which is nice, and it's just a little bit easier to manage, I think. You can kind of pick what you want. It doesn't have the graphical interface, so if you're used to like booting up to X Windows, then that won't work. But that's okay for us because we're just going to use the SSH connection to the Pi. So okay, so the last thing is the 5-volt connection here. So I'm going to connect this to the 5-volt line that I broke out earlier. So okay, everything should be wired up. And the Pi, it's right here. I've got the SD card in it, and I'm just going to boot it up. So we'll give it power. And nothing exploded, so that's good. No fires yet. And maybe, let's see, while this boots up, we can jump to, oops, the cat cam over there. So she's right behind me, sleeping away. This is kind of, I guess, late afternoon, so cats don't really do much until, you know, maybe the evening hours when she comes out. So, okay, let's see if this is done yet. We'll jump to the desktop, and let's see. I will go to a terminal here, and once it comes up, so it's connected just through a little Ethernet cable to my network, and I should be able to SSH into it once it joins the network here, and it usually takes it maybe a minute or so at most. The first boot up is usually a little bit slower sometimes for it to get connected. The other neat thing too, I'll show a useful tip if you're using Linux and you're doing a lot of Raspberry Pi development. You might not know. So normally when you erase the SD card and start with a new operating system, and you try to SSH into it, your computer will see, hey, the computer you're connecting to might have a host name Raspberry Pi, and if it doesn't match an old operating system that you had, SSH will freak out and it'll say, hey, wait, this host signature has changed, something's wrong here, and you have to go in and remove the old previous settings for your old operating system. But you can actually configure SSH to say, for certain hosts like the Raspberry Pi, ignore this authentication check or ignore this previous host signature check, and it's a special file inside of your .ssh folder, and let's see, yeah, it's the config file. And so inside of that file, there's this line I have here, host Raspberry Pi, strict host key checking no. So that basically tells it anytime I connect to a host called Raspberry Pi, don't actually look and see, have I connected this before, is it a new host? Makes it a little bit simpler, a little bit easier sometimes to work with this. Okay, so it looks like we're connecting. It's asking for the password. This is just the default Raspberry, and I think I mistyped it, so we'll see. Yep, mistyped it. So, okay, cool. Connect to the first time. Very first thing I like to do is go into Raspi Config. So this is kind of the little system to let you modify some of the state on the Raspberry Pi. We'll expand the file system. So Jessie by default, Jessie Lite uses I think like 1.3 gigabytes. This is an 8 gig card. We're not going to need a ton of space, but you know we should do this anyways. The other big thing, and this trips a lot of people up when you're using I2C devices, you need to go in and actually enable the I2C bus. And so that's in the advanced options, and we go down to I2C, and it'll ask you, do you want the I2C interface to be enabled? Yep, I do. It's going to enable it. And then do you want the kernel module to be loaded? And yeah, I do want that. So that's doing two things. On the /boot partition of the SD card, there's a special config text file that kind of configures the device tree that defines kind of how the kernel is booted and different options for it. So that turns on I2C inside of there. And then it also needs to load an I2C kernel module that tells it, hey, create an I2C device, and so that I can actually talk to my devices. So after I do that, let's reboot the Pi, and that's going to resize the drive. It'll give me a little more space, and then it'll also enable the I2C interface. And give it here a second to boot up, and we'll come back to it. So I'll show real quickly also the guide here. So it's on learn.adafruit.com. It's the Raspberry Pi physical dashboard guide, and it kind of walks through the whole process. Oops, let me see if I can hide this display. Come on, go away. Let's change pages here. So the hardware for it, this kind of walks through everything you need to build the project. It's pretty straightforward and simple, like I was showing before. So you can use the LED backpacks like the bar graphs and alphanumeric displays. Now in this example that I'm going to do live here, I'm not actually using the automotive gauge, but it's a cool thing you should check out in the video. There's a little stepper motor that's used for like an automotive dashboard, and you can use that to show, you know, a gauge of, you know, I have unread email as an example in here. It's kind of a fun little thing you can do with it. So let's see if this has connected or is finished booting up. So we'll try to connect again. So yep, looks like it's up. we connect with Raspberry. Okay, so initially what we want to do is we want to be able to look at the I2C bus and actually see what devices are on there. And to do that, we need a few tools installed. So first, let's do an apt-get update. So this is going to go in and pull down the latest version of all the package metadata. Basically, Raspbian is based on Debian, which has a really rich system for downloading kind of packages of software. And it's good when you first get started to go and update your packages, especially after you reinstall the operating system. The software doesn't change that often, but sometimes you might get like a security update or a patch or something like that that's useful. So this takes about a minute or two. It's going to go to the Raspberry Pi software mirrors and pull down kind of the latest package versions. And so while we wait for this to finish, maybe let's jump back to the cat cam. So not much has changed on cat cam. Same old cat. So we'll come back here. Looks like it's almost done. So it just downloaded all the metadata, and now it's reading the packages, which just means it's kind of looking at, I don't know if it's XML or what format it uses. I don't think it's XML. I mean, Debian's been around a lot longer than XML has kind of been in fashion. Okay, so it's finished loading that. Now the package we want to install, so we'll apt-get install I2C-tools. So this installs the I2C tools, and in particular there's a really useful one called I2C detect, and that will go and actually query the I2C communication bus to see what devices are connected to it. So each device has an address, and based on that address you can see what's on the bus, and we should see, if I've wired everything up correctly, 3 devices on the bus once it runs here, once it finishes installing. Okay, so it installed, and the way we run this is sudo I2C detect, and let's just run it with help. So it shows, and actually that's not the best help file in the world. You can use the man tool to look at the man page for this. So let's do I2C detect, and this will tell you a little bit about it. So there are a few useful options that I usually use. The -y option, for some reason it always asks you, are you sure you want to probe the bus? And you do have to be careful. Like, this is actually going to send out, the way it works is it it looks like it makes a write to the bus for each address. So it goes through each address on the I2C bus and says, hey, is there some device there? And if it gets a response from the device, then it actually says, okay, yeah, there is something listening on that. But it's technically, you know, some devices might not work well if they get a write they don't expect like that. So we use the -y just to skip that. There's some other options here that you don't have to use all the time. Sometimes there's like this receive byte, which changes how it does the probing. But let's just do sudo I2C detect /yes. Now it does take the I2C bus as a parameter. And this is kind of a tricky thing. So on the Raspberry Pi there are 2 buses, and it changed with like old versions of the Pi. So I'm using a Raspberry Pi 2 right here, and for most Pis you want to use bus 1. And I think if I remember correctly, it's dev I2C, let's see the devices, yeah, so I2C-1, that's telling me that I have a device with bus 1, or an I2C communication bus. So okay, so I ran that I2C detect, and you can actually see this is actually showing a grid of every single possible I2C address, and there are 3 things that show up. So there's 71, 74, and 76. And luckily that's exactly the address of the 3 different devices that I have here. So I know that those devices are connected, and their microcontrollers, or their controllers on there at least, are listening and able to respond. So things should hopefully work. So let's kind of move forward, and we'll go and we'll just set up the dashboard. So I'll go to the software page of the dashboard guide, and we'll grab the link to install this. And so it's pretty simple install. First we need to do a little apt-get package install. I've already done the update, so I don't need to do that again. And what this is going to do is install a few packages that this needs. So we're going to install Git, which is the source code kind of version control system, and we'll use that so we can download the code straight from the GitHub repository that has it. We're going to install Build Essential, which is basically just going to make sure you have the GCC compiler, enough of the basic compiler tools and headers that you can actually compile C code, because some of the Python packages that we depend on need to compile some Python extensions. Curl, we'll use that a little bit later. That's a tool to make HTTP requests, so you can talk to like a web service. Python-pip, this is the pip package manager. And this isn't one way to install it. You can actually download, there's a gitpip.py file, and you can run that. It's easy enough to install this little package though from Debian. And then Python SM bus, this is the Python I2C communication driver. And Python dev, this is installing all the headers that you need to compile Python code. So if you ever get an error when you're installing like a Python library that says, I can't find python.h, then that actually means that you're missing the Python developer tools. So it can't find the main header file that it uses when it compiles a Python extension. So the way to fix that is to apt-get install the Python dev package and then retry the install here. So it's little things that kind of trip you up, unfortunately, over time, that you kind of learn that, in general, if you're installing something from Python or that uses Python on the Raspberry Pi, it probably has an extension that it needs to compile, especially something that talks to hardware, because most of the Python code is just going to call C functions. And so whenever it has to talk to C, you're going to need to compile a Python extension. In most cases, there are actually some other fun ways to deal with it. So, okay, so this is downloading. This takes a few minutes or so. Looks like it's getting the Python developer extensions right now. So it's almost there. And actually what we can try real quick, so it looks like this will probably take a few minutes. I will load up a game and we'll see if we can play something here. So I've got Steam, and I was trying this earlier. I'm not sure if it's going to come up well on the stream, but we'll see. So this is a fun game. This is called Nuclear Throne, and it's a little independent game from Vlambeer Studios, which are some guys. Oh, my mouse is kind of going wild. So let's see. We'll see if we can load this thing up. And it's kind of in a retro style. The best way I can describe this, it's like Robotron 2084 meets a roguelike game where it's, like a random kind of thing. So the whole idea of the game is very action-oriented. You just control a little guy, and let's see, we'll just do a normal game. So you've got these little mutants, and you're in kind of a nuclear wasteland kind of world, and you just have to go around and just fight things, basically. So we'll just have it pick a random person. And it's pretty action-packed. So, okay, so this is me in the middle. I'm this crazy thing with a bunch of eyes. And you move around with the WASD keys here, so kind of like you're in a shooter. And you've basically got a gun, so you can fire, and you can actually hold two weapons. And so you walk around, and we need to find some things to take care of here. So yeah, it's a lot like Fallout, but kind of a little more retro arcade kind of action. So all right, we're going after these guys. Now it's pretty tough, unfortunately, as far as my health is in the corner here. I have eight health, and once you die, once you lose all your health, that's it. The game's over. So it's not very forgiving. It'll definitely creep up on you, the difficulty. All right, so we got to take these guys out. You can get some different weapons here. So there's like a crossbow. We'll pick that up. So this one's kind of neat. We've got a little sight here. So it looks like about halfway done with the Python download. So let's see. Here's the last guy. Let's see if we can take him out. Oh, there we go. And then it sucks you into the portal at the end there. So on to the next level. Now there's a neat mechanic. After this level, we'll probably see, oh boy, some bigger enemies right now. Let me switch back to my pistol. So there's a mutation mechanic that's kind of neat, where you level up, and then between levels you can pick a mutation that's like an enhancement that'll kind of permanently stick. Well, let's go to the crossbow. Oh, come on. Alright, let's take this bigger guy out. Ooh, machine gun, let's go for that. Oh boy, lots of things going on here. Uh-oh, low on health. This could be bad. This might end quickly. Alright, let's take this guy out. And see what's up here. The last guy. There we go. Alright, on to the next level. Alright, so this is the mutation I was talking about. So this is kind of neat. You can basically pick an ability here that will stick with you. So I can go for more hit points and ammo. I can go for an extra chest that might spawn, more max hit points, or more hit points from medkits. I'm going to go with more max hit points. We'll play defensively and see if we can keep the health up, because the difficulty definitely ramps up pretty quickly. These are kind of the first early stages here. Whoa. Oh, you can see between levels. Oh, so this is a boss that comes up, where basically, whoa, someone that's a little harder to deal with. Oh man, I gotta get some of this health. All right, let's see if we can take this guy on. Oh wow. Oh, that's it. I did not reach the nuclear throne. So, all right, let's see. I think I probably have time for one more match here. We're about 71% on this install. All right, so it starts me back at the very beginning again, unfortunately. So we're stuck here. Let's see. And I can't remember how many levels. There are quite a few levels. Ooh, the assault rifle. Okay, let's take that. Let's see if take these guys out. Oh. Dodge that shot. All right, let's go down here. See what's in the chest. Max bullets. All right, took that guy out. Let's see what's over here. Now all these levels, they're randomly generated, which is kind of the neat thing. So that's why it's kind of like Rogue, where it randomly makes levels for you as you play. So, okay, yep. Oh, looks like I went up a level. And let's see. All right, so here are the mutations. More hit points and ammo drops. Some kills regenerate ammo. That sounds pretty good. No damage from explosions and fire when low on health. And most hit bullets become ammo. Let's do some kills regenerate ammo. That could be useful. Because ammo can be an issue here. Wow. That's just starts you right off in the action. Oh, man, wow. That took me out real quick. All right, let's see. So we're still waiting on this download. I don't know why. Unfortunately, it's, wow, 23 kilobytes per second. This is a little bit slow, so we'll give this another minute here. Looks like it says about 6 minutes, so I'm glad, luckily, that I have this game handy. We can play here while we wait. If this really takes too long, I have an SD card that's already set up with the code, and maybe I'll jump to that if it looks like it's going to be a little bit longer. Of course, you know, you do something live, and nothing ever kind of goes the way you expect it, so... All right, let's see. Take these guys out. I hate these little larva things because they explode into a bunch of other enemies, so you got to be careful about them. Let's see. What's in the chest? Ooh. Usually weapons. The slugger. All right, let's see what this is. This is... Wow, looks like a big gun. Now you have two guns, so you can switch between them with the space bar. So I'm going to stick with the pistol until I need the bigger gun. Let's see. Get some ammo. And there's got to be someone left. It hasn't spawned the exit yet. Ah, there we go. Alright. There we go. Took him out. Alright, 99% done, so almost done downloading. And then it's got to do a little bit of an install. It's pretty quick. Alright, let's see what we can get. Get full hit points and some ammo. Oh, so that's one other fun thing. This is definitely an old school, difficult game. Basically, between levels, you don't gain your hit points again, so you've got to go in and actually find health again. Let me move this over so you can see it. Let's see. Extra chest spawn. Prevent death once. Ooh. Recharges at full health in the next arena. That sounds pretty good. Push through a limited number of walls. It's something I haven't shown yet, so you do have abilities in here, and I don't even know what this character's ability is, so if I right-click, it looks like it doesn't even really do anything. So some of the characters have abilities like they can charge and do things really quickly. Let's see. Wow, not a lot of enemies yet. Let's see if we can draw some of these guys out. Whoa. Uh-oh. Oh, man, that guy. Whoa. Now, luckily, I got that ability that's going to respawn me if I die once on this level. Let's come back to that. Let's see if we can... I do have the bigger weapons, so maybe I should come back and... Alright, looks like we're still installing the package. Almost done, though. Alright. Took that guy out. Alright, let's go back down to that big scorpion thing. And let's change to the bigger weapon. Oh yeah, there we go. That was easy. Let's see. Laser pistol. Yeah, let's try it. Oh yeah, that's nice. Alright, took him out. Oh, unfortunately. Okay, good. Yeah, good. Got the chest. That's one fun thing. When you finish the level, when you kill the last enemy, it just spawns you right out. Wow, right straight into action. There's no resting in this game. Oh boy, look out for that. Oh, now the laser pistol, it's an energy weapon, and uh-oh, great. Now we've got a few more things to deal with. Uh-oh, wow. Let's get over here. All right. Yeah, let's take the big weapon. Oh boy. All right, there we go. Good. Took him out. Oh boy, wow. Those things explode. That's kind of annoying. Oh, come on. There we go. This is probably not the best weapon for small enemies like that. All right, looks like our packages are installing in the background, so just another minute here. Wow. These guys are moving quickly. Oops, that was a waste. Oh man, alright, let's go to the laser. Alright. Wow, lots of big enemies there. Oh, I want that health. Alright. Oh, there's a shotgun. Let's see, oh boy. Let's replace the laser pistol. Uh-oh, that was bad. Oh, now I've done it. I've clicked out of the window. All right, that was a close call. All right, looks like it's unpacking the packages. So normally this is pretty quick, but we're almost done here. Uh-oh, low on health. This could be fun. Oh, the shovel. There are melee weapons. Let's see what it does. So wow, so it's got like a small area of effect. There we go, took him out. And that should be the last. Oh boy, that's not the last enemy. There we go. Alright, next level, let's see. And let's check up on this. So, yep, still installing. Put that in the background there. Alright. So we're almost ready. So it's installing Python dev. Basically, this is kind of the last part. The Pi is not the fastest computer in the world, but it's pretty quick. So okay, well, let's see. What can I mutate? Higher ammo, better accuracy, more melee range, or less enemy hit points. Let's do less enemy hit points. That seems like a smart thing to have. Don't get hit, it tells me. Okay, yeah, that's good advice. Oh boy. All right, took that guy out. Whoa. Oh man, one hit. Ouch. That's that. All right, I think we're done. I think we're ready to go finally with the software install here. So, installing Python Pi ASN1, rsync. This is basically all stuff. I think Python Pip. Yeah, it's installing Python Pip right now. Python SM bus. So this is installing the Python I2C driver, and this is actually. It's installing a precompiled version. If you install SMBus through pip, then it would actually compile it, but this should be a little bit faster because they've got a precompiled one in the Debian repository. So we're just waiting a second here for this last thing to go. Another thing too I'll show off, so what we'll do is we'll hook up to Adafruit IO and show sending data down to the dashboard once it's ready to go. Now I do have something that's hooked up to Adafruit IO already, so let me show my little ESP8266 based data source. So let's make a new dashboard. We'll call this Pi Physical Dashboard. And let's make this. So I already have a few feeds. And if you haven't seen Adafruit IO before, it's in open beta right now. It's basically the Internet of Things service that we've created to help you get kind of hooked up and started with the Internet of Things really easily. Because there's a lot of barrier to entry right now, especially if you want to do things with web services. You basically have to roll your own thing. Like there's some services that are out there. Adafruit IO is kind of a way to build dashboards and send data using MQTT protocol. So you can connect your devices up and talk to them, have them send data and receive data. And so we'll kind of show both those here. Now I've got a few feeds, so I'm going to create just some gauges to show those values. So I have a humidity and a temperature sensor value. So let's choose the humidity, and so this is a value in percent, so it's like the percent of humidity. So we'll create that block, and this is basically a little sensor I have connected to an ESP8266. It's a DHT22 sensor, so a real simple little low-cost temperature humidity sensor, and you can see it's showing data. And then I'll show also the temperature sensor. So we'll say pi temperature, choose this, and this is temperature in Fahrenheit. So let's go from like -40 to 120. Hopefully we don't hit those extremes, and so we'll say Fahrenheit. So about 70 degrees in here. So okay, so finally we're done with that install. So what I just did was install some packages. So I basically installed Git, Build Essential, Python pip, kind of bootstrapping all the dependencies that I have. So we'll come back to this Adafruit.io dashboard. Let's first get the physical dashboard set up. So next step is cloning the Git repository. So let's do this now. And pull this down. And yep, that's pretty quick. And let's go into the directory then, the PyPhysical dashboard. And we'll just show it's just a bunch of Python code in here. So it uses Flask. It's a little HTTP library, like a server library. And I'll walk through the code real quickly in a second. So the next step, I need to use pip to install using this -r command. And that basically tells pip, I'm going to give it a file. Go through that file and install everything that the file mentions. So it's this requirements.txt. This is kind of a convention in Python. I don't know if it's a strict a thing that like every package enforces, but generally if you see a requirements.txt file in Python code, it means that you're supposed to pip install it with that -r option, and it just sets up everything you need to use the library that you're about to use. So this is actually going through and it's installing the motor hat and the GPIO library and the LED backpack library. So these are all libraries that we already have on GitHub, and you can look at, there's like the Python LED backpack guide and the Python motor hat guide. And we won't use the motor hat, but it's a dependency here because in this dashboard, you can set it up and use that automotive stepper gauge. So this is going through, and actually you can see running that setup.py for the spy dev. This is where it's compiling a Python extension. So you can see it's invoking the GCC command. And so if I didn't have that Python dev package installed, I'd get a failure right there that says, hey, you don't have python.h. So okay, so that installed everything. And now to use the dashboard, we have to go in and change the configuration. And actually, I'll use a better text editor here. So let's open up the Atom text editor. So this is just a fancy little text editor. Well, it's not that little actually. It uses HTML, and it has like Chrome V8, kind of their Chrome JavaScript engine inside of here. And so this is all written in JavaScript, but it's really nice. It's called Atom. It's from GitHub actually. The developers at GitHub. It's open source. It's free, which is nice, and I like it. It's the best way I could describe it. It's kind of like Emacs, but JavaScript based, and a little more modern. It's maybe more similar to like Sublime Text, TextMate, some of those text editors. A lot of people get really religious about text editors. I don't really care. It's it's a tool to use for certain jobs and things. So let's open up the file, and first what I want to do is I'm going to connect to my Raspberry Pi using Ubuntu. So the nice thing with Ubuntu, you can connect to an SSH device and view its file system. So I've got a little shortcut here that this just connects to my Pi, and now that I've connected in Ubuntu, Atom should be able to see that. So I can actually open up a folder and go in and see. So there's my Raspberry Pi, and let's go into that physical dashboard location, and this will open up a new window in Atom, and now it's actually hooked up, and so I can edit files on my computer here, and behind the scenes it's actually going to go and just send that file to the Raspberry Pi. So this is the data that's inside of that physical dashboard, so it's all the Python code. And let's go in real quick, and the first thing I need to do is actually configure the dashboard. So there's a config.ini file, And this just defines what gauges and things I have on that dashboard. By default, it's all commented out, but we can uncomment things to enable them. So I'm going to uncomment this CPU 7-segment display. And the way things work, each section, which is kind of denoted by the square brackets here, that gives a name for this display. So let's actually call this one the slider. And so this is the top. You pick the type of widget. So this is a 7-segment display. Further down in the config file, I have examples of there's a bar graph widget, alphanumeric widget, and then the automotive gauge widget. And so this just configures kind of how the component works. So like if it's a 7-segment display, it can show numeric data. If it's alphanumeric, you can show like up to 4 characters of text. The address, so this is important. This is the I2C address, and that's what we saw with that I2C detect command. So you can see address 74, and that's just on the actual display itself. I've bridged the little address pins to say, okay, this top 7-segment display, it's actually the large one on top, is address 74 or hexadecimal 74. Decimal digits, this is how many digits after the decimal point I want to display on here. So if I'm showing a numeric value, decimal digit 0 means don't display any decimal place digits. And so for this larger display, it actually doesn't have decimal points on it. So I don't want to display any decimal points because they wouldn't have any meaning on here. So okay, now I'll configure a few more displays. So I have 3 displays total on here. This memory one, this was kind of from the demo that I did in the video, but let's call this one humidity, and this one is address 76. So this one shows a few different options. Decimal digits 2, so this will show 2 digits after the decimal point, which that's pretty good because humidity is only going to go from 0 to 100%, so we can show a little more precision on there. There are 4 characters on this display, so I can display like a value of 99.99. Invert equals true. This is an option. If you turn this on, it'll flip the display over vertically. So I don't actually want to do that, but it's good to know you've got some options in here for things to play with. And then the last one, let's put the temperature in. And so I'm just uncommenting this, and I'm going to change the name to, how about temp? And this is address 71. Decimal digits, let's keep this at 1. So this is going to show temperature. It's in the 70s or so, but you could potentially, maybe if it gets really hot in the hundreds, you might want to show that. Justify right equals false. This is another option where by default it's going to push the number to the right side. If you disable that, it's going to push it to the left side of the display. Let's disable. We'll just keep everything justified right. Now everything else is commented out by default, but this is just showing some of the other widgets that I'm not using here. So okay, so I changed the config, and let's actually run the server, and I'm going to do something real fast. Let's change our view so we can get kind of everything in view here. Let's do the workbench. So okay, so this is a workbench over here. This is me, and you might see in the upper corner, and it's probably a little hard to read, is the desktop. But I'm just going to run the main.py. So sudo python main.py, and this is going to run the server. So it loaded the configuration file, and it's telling me that the server is running. So it's running on port 5000. And actually, let me switch. Let's do a desktop-centric view. So you can see I ran the server. It found those widgets. So it told me it loaded widget slider, humidity, and temperature. And now it's saying, okay, I'm running this server. And let's actually go in, and I'll show you what we can do. So I'm going to connect to the Pi again with a different connection. Raspberry Pi. And now let's use the curl command. So curl will make a web request, and basically the way the physical dashboard works, you do a post request, an HTTP post to a certain URL, and each widget basically has a different URL, and you can send it data. You can send it a new value. So I'm going to send it, I'm going to use this data option. This tells curl to do a post request and to send some data with it, and the value equals, let's just do 100. And then the URL that we send this to, well, actually, before I do this data, let me show you something that's a little more useful. So actually, by default, the server has one endpoint that will list all of the widgets that are connected to it. So let's connect to localhost 5000 because I'm running on the Raspberry Pi, and I'm actually running this script on the Raspberry Pi, or this curl command on the Raspberry Pi. I just need to tell it, hey, connect to yourself, to localhost. I could run this command, and actually, what the heck, let's do it. Let's run a command from my machine here that's on my network. And so this is actually my Ubuntu machine here, and I'm going to run the same curl command. Let's curl HTTP Raspberry Pi, so that's the address of my Raspberry Pi, or the host name, port 5000, and widgets. So this is going to do a get on the widgets URL. And you can see it actually returns a little bit of JSON data here. So there's a bit of metadata for each of the widgets. So telling me there's a 7-segment display called slider, there's another one called temp, and another one called humidity. And it kind of tells you, hey, here's a description, what kind of data you can send to it. So that's cool. So that's telling me that my configuration is good. And like we saw, it loaded those widgets. So we'll go back to the Pi now, and we'll do the same curl stuff. So let's actually set one of these. So let's go data, and I need to set value equals something. So when you send data using this post, you send kind of name value pairs where you have a value. So this value is actually called value, and it has a value equal to, or sorry, the name is value, and the value is 100. I'm going to go to localhost 5000 widgets / the name of the widget. So let's do the slider widget. That's the tall one at the top. And when I hit this, you can see over here the top little display lit up with 100. So let me switch to kind of bigger view of it. So let's light them all up just to kind of test them. So let's go, let's light each of them with 100. So we have slider, we have humidity, which, oh, interesting. So I forgot that it does this. Basically, the Python library, if I send it a value that's too long to display, it's just going to show 4 dashes to say, oh, I can't display this value. And remember, for this one in the INI file, I set decimal digits equal to 2. So I'm actually changing this top one here, this humidity value. And so it's trying to display 100.00, and that's 5 characters, so that won't work. So let's actually change this to, so I could drop the decimal digits down, but I want to keep it at a little bit higher precision. So let's say 99, and now we can see 99.0, so it's showing the data. And let's do the temperature one. Now this only has 1 decimal digit, so I should be able to do 100 on this. Let's try it. And you see 100.0 down here. So that's cool. So that's the basic dashboard. Basically, if you follow the guide, you'll get something like this set up. And the cool thing is, let's label this. So I'll put some labels here just with chalk. So we'll say this is my slider. This is my humidity. And this is my temperature down here. And we'll put an F for Fahrenheit. And so that's kind of showing the versatility of this physical dashboard project, where it's, I'm using chalk there that I can write on the little chalk foam board and kind of label everything. And then I can just erase this and start over when I want to change these. So, okay, so now let's actually have some fun here, and let's hook this up with Adafruit IO and display those data feeds that I was showing earlier. Things like I'll show a slider that we'll put onto a dashboard and change this top slider value, and then we'll hook it up to read that temperature and humidity feed here. So to do this, what I'm going to do is use our Adafruit IO Python library. So it's on our GitHub repository here. Oh, interesting. It's telling I've signed in with another tab. It should be okay. So if you go to this io-client-python repository, this has a little Python client library. So it's real simple. Basically, you can talk to the Adafruit IO service using MQTT. So it's using like PAHO, which is an MQTT library, and it just simplifies it a little bit, gives you some easier to use APIs for it. Or you can also use a REST API that is good for like kind of pushing values one at a time. We'll use MQTT though, because it's nice in that it opens a connection, it keeps that connection to the server open. It's a good way to quickly send and receive data. And I'm going to start with just our MQTT client example. And before I do this though, I need to install some more software on the Pi. So when I'm on the Pi, I'm actually going to use the pip command, and we'll do pip install Adafruit-IO. So we actually just recently got onto the Python package index, the Adafruit IO client code. So you can just pip install Adafruit IO, and this gives you the client code that you see from our GitHub repository here. So I've got that installed now, and let's go into that physical dashboard directory, and let's actually create a new file inside of here. So let's make a script, and we'll call this, how about AIO dashboard.py. And I will start just by grabbing the example code inside of here, and we'll just paste it in and use this as the base. And you'll actually see the code is pretty simple, because all I need to do is connect to Adafruit IO, listen to a few feeds, and then when I receive data from those feeds, make a web request against localhost, do that post request, like basically the curl command, and I'll show you a Python library that can do that pretty easily. So, okay, so there's some configuration I need to do here. I need to put my Adafruit IO key and my Adafruit IO username in here. So I'll put my username, tDecola. The key, what I'll do here, so I don't actually have to show it, I'll make a file called key.txt in this directory, and I will drag this over and actually set this on another machine so that I can load my key into here. Let me, refresh this. Yeah, so I'm going to go to Adafruit IO's website just off camera here, and I'm going to grab my key, and it's actually on your main dashboard page. There's a little key button you can press. Click this. Oops, didn't copy that. Okay, so I pasted my key in there, and let me close this file just before I drag it back over. Oops. Okay, so all I did was just created this key.txt, and what I'll do in my code here is I'll actually load it up. So I'll do with open that key.txt, and I'm reading this as key file. So this with syntax, I can't remember the name of what they call this in Python. Actually, I might have it handy here. So if there's one page that you remember for Python as kind of the be-all, end-all page, look for this built-in types documentation page. Basically, almost every question you would ever have. Oh, I'm sorry, I totally need to change screens here. Let's go to desktop view. So this page here with built-in types, this has pretty much every type in Python and all of the functions that they expose. So I think it's called a context manager, if I remember correctly. Oops, press the wrong keys there. So yeah, context manager types. So these are basically types where you can have code that runs when it's when your execution starts and when it exits that block of code. So you might think of it like in C and C++, like you have constructors and destructors. This is a good way to like deal with resources. And so all of the files in Python have this context manager type assigned to them. So like this open command can actually return you back a context manager object. And so that's what that with command does. Is basically when the Python code gets to this point, it's actually going to open the file. And then because I'm using this context manager, when it leaves this block of code, it's going to make sure that the close command is called on that file, so that it, in general, when you open a file, you should close it. Python, when you exit the script, I think it actually goes through and closes the open files, but it's best practice here. So this is an easy way to do it. And so this is telling me, call this open command and give me back that context manager, call it key file. It's going to give me that file. And so what I want to do is set my Adafruit IO key equal to keyfile.readline.strip. And so this is just calling a few different functions on the key file. It's going to read the first line, and then strip will actually remove any white space from the beginning and the end of it. So this just makes sure that I get my key value inside of there. And so, all right, so I'm going to save that. Now, by default, the example here is going to connect and subscribe to a feed called demo feed. Let's make a new feed called dashboard, and let's call this dashboard slider. So we'll first listening for feed changes, we'll say. And the nice thing is that feed will automatically be created. I don't actually have to go into the Adafruit IO UI and create this feed. Now there are 3 functions here. There's connected, disconnected, and message. And so these are called when different events happen, because this MQTT library is kind of asynchronous. So events will happen. You have to plug in callbacks to say, okay, when I'm connected, call this connected function up here. And once you're connected, it's kind of a good point to say, now I want to subscribe to certain feeds. When I'm disconnected, I can just say, hey, something went wrong, and exit the program. And then message is when new data is received for a feed. So it'll pass in the actual feed name and then the payload of data that was received. So by default, it's going to print out the feed. So if I set this up, I'm not going to do anything else. I'm just going to have this print the data. So I save this file. The other important thing, so to use this library, you create a client object. I'm passing it my username and my key that I created ahead of time. I set up those callbacks. I call connect. And then you have to have some code that runs in the background to actually pump a message loop that's talking to the server and saying, hey, do you have data yet? Do you have data? And that's what makes it respond to all those events. Now, there are a few ways you can do this, and the comments show some different ways. Like, you can actually run a thread in the background that will run the message loop, and you can go and do your own processing in the foreground. The other option is you can actually pump that message loop yourself. So there's this client.loop function, and you can basically call that, and then inside of your loop you can do other processing. So this is good if you can't use a thread for some reason. There are some cases, especially like GUI applications, you have to be careful about threading. Like I've done some Qt applications with Qt, and it can be a bit of a pain. Or even dbus, which is like the kind of message bus for talking to different services in Linux. That can be a pain with threading. The last option is this loop blocking, and this actually will run the message loop inside of the MQTT library itself. So your code will actually never return from this. So this is a good option when I'm only dealing with event-based stuff. I don't actually need to do anything else myself in the background. And that's what I need to do here. So I don't actually need to do any processing. I basically need to connect and then just wait for my callbacks to occur here. So like this message callback in particular, which happens whenever message is received from the server. So I'm just going to use that loop blocking function because it's a little simpler. Oops, clicked out of there. It's a little simpler and easier to deal with. Like sometimes when you have multiple threads, things get a little challenging in that you have to deal with race conditions if you're dealing with data communicating between threads. So wherever possible, keep it simple and don't use threads unless you need to. So okay, so I save this. Let's actually run this script, and I don't actually need to use sudo to run this because it's just going to talk to the network. So there's no hardware that I'm accessing. In a lot of things, like if I'm accessing I2C, you usually need to be root. I think there are ways you can set up permissions so that like a certain account wouldn't need root, but by default it's pretty easy just to use root. So all right, so let's run that aio dashboard.py. So connected, and it's listening for changes, and it actually told me it received a new value, 35. This is just something that happens whenever you connect to a feed with MQTT. It'll send you that initial value. It's good for kind of bootstrapping, like if you have a little Arduino project that needs to know when it connects, like what's my initial value, you'll get that event. So let's actually go to Adafruit IO, and let's go to this dashboard. So I've got this physical dashboard, PyPhysical dashboard basically. And I've already got these temperature and humidity values here. So let's add a slider for the slider I just created. And I called it PyDashboard slider. And let's choose this. And we'll say label slider. Value. So since this is that top 7 segment display, or 4 character 7 segment display, I can use up to 100. So we'll go from 1 to 100, and we'll just say value as the label. So okay, so there's my slider. It has a value of 35. Now if I go to the code here that's running, and if I pull this over a little bit so we can kind of see both these at once, let's move the dashboard, and let's change this. So let's change it to 74. So cool, so we saw the dashboard, the feed value is changed. So if I change it to like 13, it goes down. So that's good. So that's telling me the MQTT connection is working. It's talking to the server, and it's actually receiving that value. So I'll press Control C just to stop that. And now let's put in some code to actually change that slider value. So to do this, I need to install another Python library. And it's actually already installed, but I'm just going to show how to install it. So let's do pip install requests. And requests is a nice little HTTP library that lets you talk to web services really easily. And oh, I didn't, looks like I had closed Python requests. And it's a great library, so it's very simple and easy to use. Like literally one function call will let you make a get or a post request. And I actually want to jump down to their quick start here, because I'm really, the code that I need to make to do that post request is this single line here. Do this request.post. You pass the URL, and then data is a dictionary of data values to pass, just like we saw with the curl command before. So let's go in and actually add this code then. So it's pretty easy to use requests. We just need to do an import statement. So let's import requests. And now what happens, so when I receive that data from the feed, it calls this message function. Right now I'm just printing out the message, but let's actually put some extra code in. So let's update physical dashboard depending on the changed feed. And let's put a little if statement in. So if my feed ID equals py dashboard slider, then I want to use the requests library to do that post request. So it's like the curl command that we saw earlier. So we want to do requests.post. Now the URL, so let's put in HTTP localhost. Since we're going to run this script on the Pi, so it should connect to localhost. The port is 5000. I want to update the widget / slider, so the slider widget. And then I need to send it some data. So you pass it a dictionary, which is just kind of key value or name value pairs. And I'm going to pass it the name value pair called value. And then I want to actually give it the value to write to the dashboard, to that slider control. And for that, I actually just want to use the payload. So that's going to be passed into this function call. And that's the value that I've received from Adafruit.io. So in theory, this is all I need to do to talk to the dashboard. And you can actually check and see like what's the response. Did the server accept it? I'll keep it simple, and we're just not going to add that code right now. But let's run this now. So, and remember, I've got in the background also, this is the web request server, the physical dashboard web server. And you can actually see it's showing me before when I use that curl command, each of those web requests. So we should see from Adafruit.io the same kind of logging there. So let's run my, wait, I don't need sudo. Let's do aio dashboard.py. So, okay, so I'm connected, and let me change, let's do a view of, let's do the workbench, and there we go. So now I'm going to go into Adafruit.io, and I'm going to go to the slider again, and you can actually see it's showing 77 because when I ran the script, it got an initial event that said, hey, here's your initial value. So let's drag the slider down, and this is 18, and boom, look at that, it updated 18. I'm going to drag this over to about 100, 100. So it's changing the value there. Drag it down to 18 again, 0. See, it's pretty quick. So you can see it's printing out what feed changed, what the value was, and it's actually making that little web request and talking to the server. So let me switch. Let's do the desktop kind of centric view here. So you can see here's the log of the server, and I'll change this. Let's change to 30. And so it's kind of tough to tell here, but so there's a post request made, and that's from the code here that's using that requests.post, and you can see it changes it to 30 on the display there. So that's cool. So that's pretty easy. We've got a slider, and I can control this on the dashboard. You know, maybe there's like a fixed value that you want to go in and change every day. So let's hook it up now. And first, let me just test and make sure that the humidity and the temperature sensor are running. And yeah, it looks like it was just last updated. I'm going to blow on the temperature sensor to change the humidity. So, and this is actually just a little, it's an AM2302 sensor, which is a DHT22. It's just in a fancy little case here. And yeah, we can see the temperature just shot up to 72. almost 100% humidity, so that's cool. So that data is working. And it's just a little ESP8266 that's using our MQTT library. And I literally took the ESP8266 MQTT example and just plugged in the name of my feed and the DHT library. I took its example of how to read from that sensor and just have it send the temperature and the humidity sensor data. Maybe if I have time, I'll show the Arduino code for it too. It's pretty simple and straightforward. Okay, so let's go and let's add code now. I guess I can keep both this view up. So now the dashboard we saw, I have a feed here that's called, and actually let's go into the edit view for this. Let's see, where is the edit view? Oh yeah, there it is, edit your dashboard. And if I edit this component, it should tell me that I'm using, interesting, I guess I can't go back to see the feed. So, but I do have these feeds ahead of time already created. So I've got the humidity feed here that I'm showing. And, oh, interesting, wow. It's beta service. There's still some bugs, unfortunately, sometimes. So it looks like going back in to see the feed on here. Actually, it's telling me right here. Here's the feed, Pi dashboard humidity. So I want to look for that feed. And I also want to look for Pi dashboard temp. So that's the temperature value. So let's put that into my code here. And it's pretty much exactly the same as what we just did. So we'll do an elif and else if the feed ID equals, let's say, Pi dashboard humidity. And we'll come back and we'll fill this in. Else if the feed ID, oh, and I noticed I have IF equals Pi dashboard temp, and we'll come back and fill that in too. So again, this is real simple. Requests.post localhost, and actually, so this is kind of one principle of programming that is really super useful. It's called DRY, dry. Don't repeat yourself. Where if you notice, like, hey, I'm writing this localhost 5000 over and over again. You know, I should probably put this in one place so that I don't need to constantly rewrite this, because what happens if when I want to change this web server, now I've got to go through and change all of these different values. So let's actually just make a variable at the top here. Let's call this dashboard URL, and we'll set this to localhost 5000. We'll give it a comment, URL of the physical dashboard. Now, one fun, tricky thing, whenever you have URLs, so I'm going to need to construct a URL. Usually you should be smart and use functions that are provided to join URLs together. I'm just going to say, by convention, don't end with a slash. So my code is basically going to assume that this never starts with a slash. Generally, you should try to be a little smarter and deal with both cases, if it has a slash, if it doesn't have a slash. But I'm just going to be fancy here and say, you know, I'm going to assume that people have put in without the slash. So let's actually use that value. So I'm going to use a Python string format command. And this actually lets me insert values into this string. So that curly brace 0, I can take a variable and have it inserted inside of there. So we'll say dashboard URL. And I'm going to do the same thing down here. So the nice thing is now I've just got that value inside of that variable, and I don't have it in multiple places. So now I want to change the humidity gauge value, and I need to pass it that dashboard URL. And now for the data, I need to pass in the payload again. So you know, this is real simple. I'm getting the feed value, the feed name, and the feed value as payload. So I don't need to do any transformation there. You know, maybe if this value came back and it wasn't exactly the right formatting that I wanted, you know, I could actually put some code in here to say, okay, take this payload value, format it a certain way, then send it to the dashboard. But luckily this is simple, and I'm just going to send that value as is. And then let's just copy this, and we'll do the exact same thing for the temperature sensor gauge. So let's do temp, and it's going to take the dashboard URL again, and it's just going to pass the value off. So, oh, and now the other thing before I quit, I need to be careful. I need to actually subscribe to those feeds. So once I connect, let's copy this and connect to those other feeds. So let's connect to my humidity feed and my temperature feed here. So, okay, so save that. Now let's go back and let's quit out of here. And let's run this now. And now, okay, wow, I've seen things change. So you can actually see values are coming in and it's printing them here. And you can see on the actual dashboard, it looks like it's updating. So let me change views here. So we should see, basically it's pulling down the values from the Adafruit IO web service here. And they're being sent from my little ESP8266 that's just right over here. So now if I blow on this sensor, we should see after a couple seconds, it's going to update the value. So look at that, humidity just jumped up to 89%, temperature jumped to 74%. So this is pretty cool. Like in 5 or 6 lines of Python, we've got values that are being sent from this little ESP8266 up to Adafruit IO. They're visualized on a dashboard over here on the web, and then I'm actually pulling them down, and I've got that little kind of glue code that's listening to Adafruit IO and then publishing that data to the physical dashboard script that I have here. So it's pretty simple and straightforward as far as the data that I'm pushing here. So there's nothing fancy. There's not a lot of boilerplate code, luckily, to write for this. So let's see. Let's jump back to the desktop view. So okay, cool. So it's me on the desktop here. So I've pretty much got the basics running here. We've got, like I said, the code running that's pulling down the new values. Actually, let me turn on the dashboard display also. So we've got that. And actually here, let's change the slider again too, just to show that that works. So yep, 72, 10, 15. So that's kind of cool. Now there are lots of ways that we could extend this, and I won't maybe go into it right now. But one idea I had is that if you've got a cool dashboard like this that's displaying data, one interesting thing is like if you have a web service and you're showing like server status, I think it would be neat to actually put like a button on the dashboard, like a big red button, that says, okay, here's the deploy code button or something like that, where you can kind of make a ritual of, okay, it's time to update the server, get everyone around, let's look at the stats, okay, push the big red button, deploy the new code. And we could actually do that. We could have a button on the dashboard. We could have a script on the Raspberry Pi that's reading the status of that button, and we can use that exact same Adafruit IO library to push values up to the service. So, this dashboard could actually be kind of a two-way, you can read data, you can also push data from it here. But that's basically all I wanted to do was show off this stuff. I don't know if there are any questions from folks. I've got, let's see, the Twitch chat open over here. Also, let's see, we'll check up on the cat cam real fast. So, it looks like the cat has moved a little bit. So, but yeah, otherwise this is just a little walkthrough of kind of the Raspberry Pi physical dashboard. And let's see, jump back to the workbench view for this. So I don't see any questions, although I'm still kind of new to the Twitch stuff. So I think this is probably it. We'll call it as mission accomplished, as successful little Adafruit IO demo with the Raspberry Pi physical dashboard. Also kind of a good walkthrough of setting up the physical dashboard, so you can kind of see exactly how to install it. You really just pull down some Python packages, install the software, modify that config file, and you're ready to go with it. So I think with that, we'll call it a day. So thank you everyone for tuning in, and keep subscribe to Adafruit's YouTube channel. You'll see more projects like this in the future. And subscribe to Twitch also, and you might see more of me streaming fun stuff like this. So that's it. We'll go back to the cat cam, and we'll call it done.